All right. So welcome everyone. This is the Beginner's Guide to Performance Tuning, the T-SQL edition. So
Do you have control?
apparently not. It
Click
says
on
I
the
do, but
thing.
there it goes. We'll see how this works. All right. So for those of you all who don't know me, my name is Deborah Melkin. I'm a SQL developer in a fintech company in the greater Boston area. I've been doing this for over 20 years now, which is kind of scary to think. Mainly work with SQL Server. I was honored last November to be awarded the Microsoft MVP for the data platform. I'm still very humbled by that, and hopefully I can live up to that title. I'm a data platform community speaker. I speak with other user groups, other events, and so on and so forth. I'm IDERA 8th class of 2020. So thanks to IDERA for having a program for up and coming speakers. Hopefully when we're back in person, they'll be able to have the next great class of speakers. My big claim to fame is I won Speaker Idol at the past Summit 2019, the last in-person one. So like I'm the reigning champ, and I'm going to go with that as far as I can. And I'm also a board member of the New England SQL Server User Group. We are the local user group in the greater Boston area. So we have events just like this, but up in Boston. Some of my contact information you can find. I'm on Twitter, email. I have a blog I keep trying to post to. I have ideas that I need to put out there. And I do have a GitHub where I have a lot of information and other session information up there as well. But this is not the important thing to know about me. And there we go. This is the important stuff to know about me. I'm the alto section leader. Where'd you
That
go?
was weird.
Okay,
Click through
come
again.
back. Come back. Here we go. The important stuff to know about me. Alto section leader of my choir. So we're looking forward to being able to make music together in person soon, hopefully. I do bluegrass jams regularly. So far, it's been safe to try to do some of those again, and I miss it dearly. I've been learning guitar, and I have a mandolin I've been neglecting learning. And if nothing else, I'm a bit of a musical theater geek. Not as much as some people I know, but enough where, me, Bernadette Peters, excited to get that picture after seeing her. Anyway, so that's enough about me. Let's see if we can get this going so we can learn a little more about Andy.
So my name is Andy Yoon, Principal Solutions Engineer, but I'm also a former SQL Server DBA and developer. I've been selling software for the last couple of years. You might have heard of Century One before, so I've been with them for quite a while now. And I've been a speaker for a while as well. Former Microsoft MVP, and I used to do a whole heck of a lot of stuff in Chicago before Deborah stole me and dragged me out to Boston. But in either case, you see my contact information at the bottom. I also kind of picked up guitar thanks to Deborah's influence as well. Been having a lot of fun with that, learning that type of thing and whatnot. So, but otherwise, that's pretty much it about me. I'm not nearly as interesting, okay, yeah, I'm Deb's personal chef, but that's about it. So in either case, you're not here to hear about us. You're here to hear about performance tuning. So performance tuning is an interesting phrase. When you first hear that phrase, think about what goes through your mind, because depending on what you do and how you work with SQL Server, there could be a lot of different things that come to mind as far as what does performance tuning entail, right? Because, are you looking at, server level metrics? Are you looking at code? Are you looking at, stuff beyond that? Are you looking at business requirements, right? There's a lot of different things that can fall under the purview or the umbrella of performance tuning. And if you want to become an expert in performance tuning, where do you start, right? Because there's so many different ways that you can attack, database performance headaches, right? So the goal or idea of this presentation is to kind of give you a little bit of an introduction, a starter's guide, if you will, from the T-SQL perspective, if you're more of a T-SQL developer, of how to get into performance tuning. So to that end, our agenda today is going to be split into a couple different chapters. The first thing is we're going to talk a little bit about why languages matter, okay? The second chapter, what we're going to be talking about is what is SQL Server really doing? And then we're going to try and cover a handful of different common performance headaches. There's no way we can cover all the major ones, even some of our favorites, in the span of just 60 minutes. For what it's worth, I want to warn you all right now, this is a 75-minute presentation that we're going to try and jam into the next 60 or so. So there is a lot of content here. But again, the idea of this presentation is to be a 100-level survey session. We're going to be sprinkling in a whole bunch of different things here. We're not going to be going into depth into anything, super major. The idea is to introduce you to a bunch of different stuff, and then we're going to give you a bunch of resources later, so that way you can say, oh, you know what, this sounded really cool, or that sounded really cool. I want to learn more about it, and that's where you can go take our different resources and dig in even deeper. So this is the starting point here, and we're just going to be fire hosing a whole bunch of different interesting little things out there. All right, so that's the agenda, and this is how we're going to do things. So let's get started. So first, I want to talk a little bit about languages matter. And of course, we primarily work with the T-SQL language. And, a lot of us have dealt with these types of questions when we're looking at our T-SQL, right? Or variations thereof. Why is it doing this? Why is it doing that? Or, like, this should have been a fairly easy query. Why is it taking so long? So on and so forth, right? So what I want you to better understand is that the way you've written your query matters because of the nature of the programming language. Now, some of us, myself included, have a computer science background, right? And we've learned, and in our background, or we might have a developer background, right? So we've learned on more traditional procedural or imperative programming languages, things like C, C++, and things of that nature, right? The thing about all of those programming languages, the ones that many of us have initially learned on, is that these types of languages dictate how to do something. Do this, do this, do this, and do this. The thing is, T-SQL is not one of these languages. Instead, it is what's called the declarative language, which instead of saying how, it says what do you want, but it doesn't necessarily define the steps of how to go about doing it. You're going to outline certain things, but the true how will actually be left up to something else, in our case, the query optimizer. So because of this key distinction, you need to approach your T-SQL and how you write T-SQL a little bit differently. And this is, in my opinion, one of the first fundamental things to understand when it comes to T-SQL performance tuning. So I love silly analogies. So we have a silly analogy right here, and this is a pasta dinner recipe. It's a fairly standard kind of recipe that you can follow, and you come up with a basic sauce and so on and so forth. Eventually, you go boil some water, make some pasta, and eventually you come up with a nice little pasta dinner recipe, right? So think of this recipe as your code, or akin to your code. So if I were to follow the recipe in a procedural fashion, I must follow the directions exactly as they are laid out. So first I must go to the fridge and get, my ground beef or my vegetables, and then I must go to the cabinet and get the first thing, and so on and so forth. And I must follow the instructions exactly as they are laid out. But notice that there are multiple times that I have to go back to the fridge, because first I have to get some meat, and then maybe I have to get certain vegetables. And, there are multiple times I have to go to the cabinet, because first I must get a saucepan, and then later on I must get a stock pot, and so on and so forth, right? So, there's different things that I have to do, but some of them are kind of repetitious, right? But if I'm procedural, I must follow that recipe exactly as it is laid out, and that's the key there. However, if I were to take it from a declarative perspective, I'm going to read the entire recipe and say, you know what, I'm just going to go to the fridge once and get all the junk that I need at once. And then I'm going to go to the cabinet once and get the stock pot and the saucepan and all that stuff that I need from the cabinet in one go. And then, you know what, my stove isn't the greatest stove. So you know what, I'm going to get the water boiling now earlier, and then I'm going to start preparing my sauce, because I know it's going to take a lot longer for my water to get boiling, as opposed to saying like step 10 or 12 or something like that, right? The key here is that I'm making some guesses as to what I think will be a more efficient route to create that same final pasta dinner, but I'm kind of making some different decisions on the fly. And this is the declarative approach. You're trying to make some best guesses possible, guesses being a key word here, based upon information that you think is true, another key phrase there, to come up with the best possible plan you possibly can in order to come up with that dinner recipe. And that's a declarative approach. And that's how T-SQL is approaching your queries. You're asking for a bunch of data, but at the same time, you're not necessarily dictating how to go about doing that. So if we come into this pasta dinner recipe, this is a 21-step recipe. One key kind of myth or misconception around the query optimizer is that when you give the query optimizer a problem, it's going to come up with the best execution plan possible. Much in the same way, back to this analogy, you have a 21-step recipe here. What's the fastest course of action so that way you can come up with that pasta dinner recipe as quick as you possibly can? If you had 10, 20 minutes to figure this out and think about different permutations, you might be able to come up with something. But here's the key misconception, is that the job of the query optimizer is to not to come up with the best plan possible, but to come up with a good enough plan quickly, because the query optimizer has a limited amount of time. So if I put you to the same challenge with this 21-step recipe, can you come up with a good enough plan in this amount of time? Sorry, time's up. Did you come up with a good enough plan, or did you come up with the best plan possible? You probably came up with something. Is it the best plan possible? Who knows? But you know what? Sorry, time ran out, and you just got to go with whatever you came up with. And that is one of the key other conceptions, or things to understand about the query optimizer. It essentially has a limited amount of time, so you don't want to throw a massive problem at it, such as a T-SQL query that's pages and pages and pages with 80,000 joins and where predicates out the wazoo and with subqueries and all that kind of thing in one single query. Right? Because it would have been a heck of a lot easier to come up with a good game plan if I just said, boil some pasta, 3 steps instead of 21 steps. Think of it in that regard, right? So key takeaway there is to think about the query optimizer and the size of the challenge that you're throwing at it, because how complex is it? Is it overly too complex in the context of a single statement? So remember that your T-SQL queries declare what data you want. Select blah, blah, blah from this, interjoin that, so on and so forth. But it'll be up to SQL Server to determine things like the access methods, whether I'm going to seek or scan and things of that nature, and I'm getting ahead of myself. So in that case, Deborah, you're up.
So this all comes to, okay, so we're letting SQL Server figure this out for us because we're giving it a query. So what is SQL Server really doing when you give it a query to execute? So let's think about the life cycle of a query. You come up with your select statement or whatever your query is. Then what SQL Server does is it goes to the query optimizer. It starts looking for the tables that are involved, and it starts figuring out the different statistics that are on those tables for the different data that you need. Then it comes up with the execution plan. So now it's going to figure out, okay, based on what's in the query, based on this information, I'm going to come up with a plan of attack. Here's how I'm going to execute it all. And then it goes to the storage engine and it actually executes your query. So this is a really important thing to think about, because when we talk about it, we kind of forget that the execution plan comes up before SQL Server does anything. It's figuring out its plan of attack. And so when you're doing performance tuning, this is really where we're focusing on, because most of the time when you're trying to do performance tuning, you want to understand your execution plan. And there is more information that we can learn from an execution plan than we can talk about here. There are books, massive, heavy books that you can read, and you still may not know everything, but there's that much information about that in your execution plan. So with that, let's jump over to the demo. Let's see if I can do that. Nope. Andy, I may need your help over here. All right. So we have this auto dealership demo database, and making sure that I'm using that, and I am going to turn on my execution plans. I'm going to do my actual execution plans right here. So we're going to do a quick survey. I have this quick little query here, and we're going to run this. And let me move this up so we have more real estate. So we only get one row, but when we look, now we can look at our execution plan. So there's a couple different things to note here. What we're looking at, it's called the actual execution plan. But as I said, the execution plan is come up with before we actually execute it. So there's a bit of a debate in the community as to whether it's really an actual execution plan or the execution plan with runtime statistics. Because now that we've actually run it, we actually know a little more because of what happens as SQL Server goes through the steps to figure things out. But there are a bunch of different things that we find out when we look at our execution plan. But first thing is, which way do we read our execution plan? Are we reading it left to right or right to left? One of the reasons you may want to read your execution plan left to right is because I read somewhere that the best description of it was it's physically what you're doing. You have your select statement and it's getting data from this nested loop, which is getting it from this cluster index seek, which is joined to this nested loop with this one and so on and so forth. What you're getting from right to left, which is why most people use that as the way they read execution plans, is because you get a flow of data. So now that you're getting from your data, it flows out and you can actually see how that works. I'm actually going to run this next query. I'm not going to let it finish because it just takes way too long, but there is a chance in Management Studio for you to include live query stats. So we can pretty much watch the execution plan and see our flow of data. So when I run this, it's kind of cool because you can sit and you can watch the lines and you see the flow of data going from right to left, and you can see all the different information and how long everything's taking. So it's really cool in terms of information, and if something's taking too long, you could actually see where things stopped and you can understand which of the operators causes that to happen. There was a great summit session last year by Forrest McDaniel where he does an animation of all of this. We have it in the resources. It's really mind-blowing, and as much as I've been working with execution plans, I really learned a lot more about the details of how all of these different things work. But it's kind of cool because you can start seeing the flow of data through the plan when you're using real-time stats. But I want to kind of go back here because there's more things I want to show, and this is a smaller and simpler execution plan. Actually, I'm going to turn off the live statistics and let's try this one more time. All right. So a couple things that we learn, we can see different things like, are we doing index seeks? Are we doing index scans? We have key lookups. This is something we may come back to later, so hold on to that. We can see how tables are joined. We can see things like nested loops, or as opposed to things like hash match or merge join. So it says pretty much how SQL Server is figuring out how to put the data together. Nested loops is you have one large table and then the other table has smaller amounts of data, so it's looping through. Hash match, equal size, matching them together. So we have that information. The other thing we get are estimates of what SQL Server thought it was going to get out of a table, like the number of rows and how much memory it thinks it's going to need, versus how much it actually ended up taking out. But the other thing is this properties tab here is actually pretty important because as you can see here, sometimes it's hard to read or there's way too much information. Let's say if I were to click here, I can get the actual information and it's a little more readable in my properties tab. I've grown to like this properties tab. Hated it when I first used it, but I like it more and more these days. But we get information like how many rows did we think we were getting? How many rows did we actually get? So when you start seeing huge disparities between these numbers, you have to start saying, well, why is that? Are my stats out of date? And you can start figuring things out from there. The biggest thing that properties tab has a lot of information. So if I go to this first node here, I've got this has a lot of the most important information. And this is usually the first place I go when I'm performance tuning. I see things like my cardinality estimation model value or version, excuse me. So this tells me what version the database engine is executing my query under. So 1500, I believe, is 2019. So right now I'm executing this as 2019. If, let's say I had this in 2016 compatibility mode, I would see a different version. And I may have different results in my query because of that. So it's really important if you're trying to troubleshoot things, making sure you're on the right version. It can explain different things that you see or different options that are available. I can see degrees of parallelism. An important thing, this was a really quick query, and I don't have any time here, but I'm actually really curious how long it took. This query time stats will tell me, and this actually really did take no time at all. But again, if you're dealing with performance tuning and you're really going into the depth, knowing this information is really useful because then you get a more accurate view of how much time these queries took. Reason for early termination. So in other words, when Andy was talking about SQL Server trying to find a good execution plan, this will tell you whether it timed out because it just had to go with what it found because it didn't have anything, or it found a good enough plan, so it's ready to go. So we can see that information here. If there were any errors, we'll get to some of those later. We have memory information here. Again, stuff we can talk about later. But again, a lot of different information that we're looking for, we can find right here in the properties. And it's the first place we can go for a lot of that basic information. So let's start using this to do some troubleshooting. So we're going to start with some data types. And people have huge long sessions about data types. And actually data types have been the bane of my existence lately because we've had too many sort of issues with them, like implicit conversions. So let's start working with that. So I have this query here, and my customer ID, if I hover over it, we can see it is an integer field. I'm going to pass it a varchar and see what happens. So I run my query, and let's look at the execution plan. And for the most part, this execution plan is pretty similar to the one we saw when I'd been running before. The only difference is I've put quotes around it to make it a varchar. But SQL Server in certain places can figure out, okay, it's a varchar, but it's really an int. I can convert it, and it works fine the way I'd expect it to. So let's start really making this different. Well, if I'm going to pass it a varchar, well, I'm going to make my customer ID a varchar and convert that, and let's see what happens. And I go to my execution plan, and I have a very different plan available to me. The other thing to note is right now these yellow warning signs. So it means something happened, and it's telling me that there was an implicit conversion on my customer ID because I have an index on customer ID, and when you convert the field that the index is on, you can no longer use the index because it's no longer an integer. It just doesn't work. So now I've got a very different plan, and I can see things like, you know, my estimation is very off, or number of rows read to get my estimate. The estimates was right, but the number of rows read was much higher. So it's a much more expensive query now. And everything else is a very different shape. So it's a very different query and slower as well because, well, we can't use our index. So let's see what else happens. So what happens if I change it to a parameter? So I'm going to declare this as a parameter, my varchar parameter, and I'm going to leave customer ID alone, and we're going to pass it in and see what happens. When I go to my execution plan, it's the one I expected. It's the same shape. It's doing the same thing. It's doing my clustered index seek, be able to look for that customer ID. It was able to figure out the conversion. Now, what happens? I'm going to do a similar thing, same customer ID into a varchar, and I'm going to do something different. I'm not actually going to convert my customer ID, but I'm going to treat it like a varchar, and I'm going to say my customer ID is like the value, and I'm not even using wildcards. Oops, did I run that? Yes, I did. So now we see a very different shape from what we did before. So first we can see the warning, and we have a complicit inversion. But now we can see things from 2019 sneaking its way into its execution plan by way of this adaptive join. So adaptive joins are, well, SQL Server knows that based on whatever data is going to come back, it may need to do a different type of join. It doesn't need a nested loop, doesn't need to do a hash match because how much data is it actually pulling back? It can't figure it out because it can't use the index, but it needs to figure it out, and it's going to decide what it is. And we actually have the definition description here, chooses dynamically between the hash join and a nested loop. The other thing it does is it tells you the threshold that which one it's going to choose. So we have all this really great information right in our properties from our execution plan. And SQL Server decided this before it ran anything at all, which is also kind of cool. So we have this adaptive join. And so now we can go through and we can say, all right, we can see what it is. Do we want SQL Server to figure it out, or do we want to kind of use the right data type to begin with so SQL Server has an easier time figuring out what it wants to do? So that's just one thing we wanted to kind of cover with that. So now let's start talking and taking this a step further and thinking about missing indexes and other things like optimizing for parameter sniffing. So let's start with missing indexes. So we have this stored procedure that is going to look for information about vehicles sold each year by state, and we're going to start with Alaska. And we'll take a moment to mock Andy for the name of the stored procedure because, well, we shouldn't be using SP underscore for the name of naming convention because that stands for system procedure. So SQL Server is actually going to look in master first, but that's a separate topic, and we'll just kind of, move along. Missing indexes. So one of the cool things about when we run our execution plan is SQL Server has a way to figure out if any indexes are missing that will help us along. So right here, when you run it, it'll tell you if you're missing any indexes. Now, the cool thing is, well, it's not cool, but there may be more than one index missing on your query, but we're only given one. So how do we find that out? If we click over to select, one thing I will give with execution plans, when you can't just click on select when it first runs, you have to click on a different node and back to select for some reason to make sure your properties shows up correctly. I don't know why that is, but I'm just used to doing those clicks at this point. But if you have any missing indexes, you will see them in your properties tab, and you can expand this, and this will give you the list of all the possible missing indexes. In this case, we're only missing one, but it tells you information like which table, which columns you want to see. Missing group, column group tells you the columns that you want to add. So we have all the information we need. One more. All the information that we need so we can create a good index, and now we can optimize our query. The word of warning on this is SQL Server's recommendations may not always be correct. Sometimes you can create that missing index that SQL Server says it wants, but then when you use it, it may not actually use it. So definitely test these out and see if they work for you.
I'm going to chime in here and put in a shameless plug. For past summit this year, I will be debuting a brand new session all about missing indexes, do's and don'ts. So come check that out in a couple of months.
Yes. So there are a lot of these little things that a lot of people have full sessions on too, but definitely pay attention to these missing indexes. So let's create our missing index here. Very simple one on our customer, on the state field on our customer. And so now we're going to rerun our stored procedure. And when we run this, the missing index is gone. So that's a good thing. We still have a couple of warnings that we may want to pay attention to. Memory grant, excessive memory grant. So we haven't talked too much about that. And this is where SQL Server has to figure out how much memory it needs in order to store the data that it's pulling back, or how. So let's go back. Let's take a look at what that memory grant is. And if we look, we can see something about SQL Server. So 2019 is where SQL Server starts introducing memory grant feedback. So if you have excessive memory because SQL Server, it's expecting more rows than it's actually doing, or it thinks it needs to hold more data than what it is, this is when you'll get excessive memory grants. But because in 2019, you can start getting that information. Is memory grant feedback adjusted? Well, no, because it's the first time executed. So what happens if we run this again? Oops. So click over here, go back to our memory grant information, and we can now see not only do we not have the warning, but we can tell that SQL Server decided to adjust. So yes, it's adjusting. So as you're working with stored procedures or any query, when you run it multiple times and it needs to adjust, SQL Server will start figuring those things out. You may want to figure out why the memory grant is bigger so it doesn't have to do that, but 2019, it will help you along. Another thing I want to show you, because we're doing a stored procedure, is this parameter list. And I think this is a cool thing that it has. So the first time you run a stored procedure, SQL Server takes it, it stores it, and it basically compiles a stored procedure based on the parameters that you give it. And we can see that information right here. So we know what the parameter is. We know the compiled value is Alaska because we've been running it for Alaska. And now we can tell that we're running it for Alaska because we have the runtime value. So what if we wanted to run this for a different state? Let's say Illinois. So let's check that out. And it's definitely taking much longer. It wasn't that complicated of a query, didn't have too much problems, but it's taken much longer. And if I go to the execution plan, this would be the same execution plan. We're not seeing anything too crazy. There are no warnings. But we can go back here and we can look at our parameter list. And we can see, well, we optimized, the execution plan was optimized for Alaska, but because we're running it for Illinois, the plan isn't going to work the same because the data distribution is different. So even though we're reusing that plan, this runtime value. And so when we talk about parameter sniffing, it's when you are starting to see the same execution plan run horribly because of the different data distributions, too much data, the data changes. This is a place where you can actually go with a stored procedure and you can find out, what did I optimize my stored procedure for that first time? And that will tell you all of that information. And then you can start working through and figuring out, okay, well, how can I optimize it for this larger data set? So we can get rid of some of those issues. So, all right, so let's reset and get rid of that index. And now I want to talk a little more about some of these costs that we're seeing and some of these estimated versus actual numbers. So let's start with estimated versus actual. I have this multi-statement table valued function, and I'm using that specifically because they have a bit of a bad reputation when it comes to performance tuning. So let's take a look at why. So as I said, it's not the best or the fastest one. So we've got our data coming back and our execution plan should be back in just a second right here. And now we can see why people don't like multi-statement table valued functions. Because when I actually ran this, I can't see what it's doing. And it's kind of on purpose because the way SQL Server is executing it, it's almost like it's running in a black box or running through a separate thread that's not fully connected to what we're doing here. So we actually can't see when we actually run it in our execution plan with the runtime statistics because we don't have that information. It's kind of a little bit of a black box. Other things are, you know, we're getting things like actual number of rows. We can still see some of those and estimated, well, because I'm just running from the function itself. But I can't, the big thing I want to know, I just can't see. But remember, before SQL Server actually executes it, it still comes up with an execution plan. And this is where you can use the display estimated execution plan to give you that information. And now we can see this first thing here is what we actually get when we execute it, that execution plan. But now we can come up with the plan for what it may be doing behind the scenes, depending on how your multi-statement table valued function is running. And so now we have all of that information, and we can see that there's a lot of stuff that's going on here in this. And this is where these get really tricky to troubleshoot, because again, we can't see it here. We have to go get to the execution plan itself. This is probably what's being run behind the scene. This is why people don't like the actual versus estimated title, because this is still our execution plan for what the function is doing. We just can't see it when we do actual runtime statistics. And it can make things really difficult when we're trying to do comparison and performance tune. Let's look at a couple other reasons why this is a little bit problem and what it means versus actual versus estimates. Because let's get the cardinality estimator involved here. So I'm going to do a cross apply with this function with my inventory table. And again, a little bit longer of a query, and we had finished. And so again, I can't see, even though I'm doing a join, because the function is executing separate, in a sense, separately from the rest of my query. But there is a big thing we want to pay attention to here. And that is this estimated number of rows. This is why a lot of people don't like multi-statement table valued functions, because prior to, because 2016 and 2012, yeah, is that right? Yeah, no, sorry, 2016, 2014, sorry. This estimated number of rows was always 100 for our multi-statement table valued functions. And that was done on purpose. It was an improvement over 2008 and 2012 when it was 1. And remember, SQL Server is using these statistics to figure out whether it's doing nested loops, whether it's doing hash matches, how it's joining to other tables. So this estimate meant it normally not have a great number of records being returned, or it could do the wrong cardinality estimate. When you do a cross apply, you're still getting that problem because it doesn't know. But with 2017 and 2019, SQL Server said, this is a problem. It's not fixing it for cross applies, but it is fixing it for joins. So let's take a quick look at that. And so it's a different query, but I'm doing it as a straight join between the function and my table. So of course it takes a couple seconds. And what we're going to see is how that estimate versus actual comes into play. So again, I still have a black box, but now I can see stuff like my estimate rows. Well, it's not 100, it's still better. It's not quite the actual number of rows, but it's getting closer. So SQL Server is able to almost pre-execute my function, figure out what that estimate is, and then it can do the joins with the other table, and it can do a better job of figuring out, you know what, a nested loop is still going to work with what I want it to do. One of the things that I haven't talked about yet are these cost numbers that we're seeing. One thing I will point out is these are great guides that we can use in our query plan so we can figure out where SQL Server is spending most of its time in its query plan. But these are kind of estimates, and I would use them as just guides because they're not always accurate depending on what you're trying to do. You can still look and say, hey, this join is costing 13% of this query. This is taking 27%, this is 30%. I can start working from there to figure out what's going on. But one of the things that I also find that I do is as I'm working and trying to improve on things together, is I may say, I have these two queries. I want to figure out which one is better. So I will run these at the same time. And what SQL Server is doing while it's executing is it's figuring out the cost for each statement. And then it's going to figure it out relative to the batch. And one of the things that I'm pointing this out with functions is it may not always be accurate. It could be, but it may not. But depending on how you're working, it's important to say, all right, this top function statement took 72% of the cost for running these two queries together. This one took 28%. Is it accurate? And it's always important to kind of look at other things about the queries that we know and figure out based on those execution plans, which one was better as you're doing troubleshooting. For example, I want to know how long this one took. This one took 5.5 seconds, 5633, and this one took 8335. Well, it's much cheaper cost-wise, but it took much longer. So now you get to figure out based on that information, which one is better. And working through your different queries and using these again as guides and all these other pieces of information available to you as your performance tuning so you can figure out, where do I want to go next? So Andy, where do we want to go next?
Oh, let's find out. Back
And
to
by the way,
slides for
are there
now.
any, yeah, were there, I know, right? Any other, if y'all have questions, feel free to drop those in the chat and we'll try to answer those as we go along. I know I just kind of, we just ran through things here.
I have been kind of trying to keep an eye on the chat to see if anything came up. I just, but no questions have been coming up. But, you know, hey, feel free to type on in as we keep going along because I got it over here on another monitor. All right, let's keep on moving then. So with that, let's pivot now into the final chapter of this particular presentation, common performance headaches. And I think we'll have time to do 2 demos tonight if I move fast enough. So there's a lot of different types of performance headaches. Deborah already touched on a handful of them, and I'm going to kind of touch upon a few other different things that I see on a fairly regular basis. Things like unnecessary looping, because with our T-SQL code, we want to try and do things in a set-based fashion, not an iterative fashion. One interesting little tidbit is that if you happen to have an Oracle background, doing things in an iterative fashion with like cursors and stuff is actually a good thing in Oracle. But in SQL Server, it's actually a really terrible thing. So that's one of those funny little nuances that I learned at one point in my career. Like, that again, if you came from Oracle, you think it's, oh yeah, this is a great way to do stuff. But again, if you come over to the world of SQL Server, no, not such a good way of doing things. Mismatched data types. Deborah, of course, has spent a little bit of time talking about that. That's something that I see on a fairly regular basis, to the point where it drove me bonkers. And I developed my very first presentation about it. So if you want to go look that up, go Google my name and look up why your data type choices matter. You can find some recordings on that. Memory grant issues. Whenever you're doing work, you need a certain amount of RAM. And the thing is, one of the biggest things about performance is that it's not only all about what your query is doing, but about the resources that it is consuming. And there's both direct resource utilization of, like, the data you have to read, but also SQL Server oftentimes needs a bit of workspace, if you will, in order to do its work. And that's essentially what the memory grant happens to be. So it's one of those indirect things that you also want to be mindful of when you're coming up with your queries. There's no way to predict a memory grant until you actually run it and then take a look at the execution plans and the details, of course. But again, something to still be mindful of. But the one that I really want to focus in on, because this is something that I see on a very, very, very regular basis, is excessive logical I/O, which is essentially all about reading too many data pages behind the scenes in an unnecessary way. You're doing stuff in a repetitious way. And you're basically just reading a whole heck of a lot of extra data because of either inefficient access methods or inefficient T-SQL, or things like nested loops, or not nested loops, nested views, which are one of my personal pet peeves as well. But in either case, it's one of those things where not a lot of people come to appreciate that. And this kind of goes back to also looking at the execution plans, the stuff that Deborah was talking about, because you might have a query that only returns 10 records, but you had to process 10 bazillion different records in order to find those 10, right? So to that end, let's talk a little bit about key lookup operations. So Deborah touched on a little bit upon that. And a key lookup operation has to do with non-clustered indexes, right? So to briefly introduce the idea of an index, let's use this analogy. We have a cookbook of recipes, okay? And this cookbook is organized by the table of contents. And that table of contents is essentially akin to your clustered index. It is defining the order of all of the different recipes in this cookbook, right? So, certain recipes are on certain pages and so on and so forth, right? It defines the order of everything. But in the back of this cookbook, you can have a number of different non-clustered indexes. Like in a cookbook, you might have a index of recipes all in alphabetical order. But of course, if you're doing things in alphabetical order, those page numbers, as far as where those recipes happen to be, are not going to be sequential. It's not going to be 1, 2, 3, 4, 5. It's going to be defined by the alphabetical ordering of the titles of the recipes, right? In addition to that, you could have other indexes in the back of this cookbook, such as by, meal course. You show me all the appetizers, all the desserts, all the entrees, and that sort of thing. This is really a bad analogy to be doing right before dinner, right? I'm starting to get hungry. Anyway, sorry, I'm being silly. You could also do it by cuisine. Maybe this is an international cookbook. So you have German, you have Japanese, you have Mediterranean, Greek, or whatever, right? So, your recipes are organized in that fashion. Or you could even do it by major ingredient, beef dishes, chicken dishes, and so on, right? So think of a SQL Server table in a similar fashion. You can only have one clustered index, which essentially is the table itself, and which defines the physical structure of the book. And you could have 0 or more non-clustered indexes that are organized in different fashions, just like these example indexes are, to help you find that data a heck of a lot faster. So to that end, let's pretend we're looking at one of those non-clustered indexes. And, so we got a couple of different recipes here, and the pointers back to the actual recipes, the page numbers here, page 16, 48, or whatever. And let's also pretend that these indexes happen to have the top 3 or 4 ingredients that are needed for that particular recipe. So you see that, bacon, cheddar, and, Worcestershire or whatever, and things like that, right? So you know what? I don't need to go check the actual recipes themselves if I'm trying to look for recipes that happen to feature bacon, because maybe I want to do something with bacon tonight, or feature rosemary, because you know what? We're growing some rosemary out back, so maybe I want to do something with rosemary tonight, right? But if there's another piece of information that I want about these different recipes, like cook time, for example, or prep time, well, I'm going to have to flip to each of these different pages. I got to flip to page 16, page 48, and page 62 to look up that extra piece of information, because a copy of that information is not materialized here in this non-clustered index. And that extra, lookup is what we call a key lookup operation. And if you think about it in terms of SQL Server, that's extra I/O that we have to do, because the non-clustered index did not include enough information. So that's one place where we can have a little bit of hidden performance killing, because we're doing excessive I/O behind the scenes. So to that end, let's do a little bit of demo on this. So, I really like key lookup operations, because whenever I find them, it's generally speaking one of those things where it's typically low hanging fruit, where you can just make an adjustment to an existing non-clustered index. So right now I'm creating a non-clustered index on my customer table, and it's going to have 3 different data points, or key columns, I should say: last name, first name, and zip code. And then I'm going to use a built-in, I'm not going to use a built-in store procedure. I'm going to use a separate store procedure by Kimberly Tripp of SQL Skills, called SQL Skills Help Index, to view more information about this non-clustered index. So in addition to the index keys, Kimberly's will also include all included columns. Of course, we did not define any included columns on this, so that's why nothing is here. But I also am running this against a customer table to show you that I have no other non-clustered indexes defined on this particular table. The built-in version of SP Help Index inside SQL Server will not show you things like included columns, nor will it show you like the filtered definition if you happen to be using filtered indexes and all that other kind of good stuff. So I strongly advocate for making use of Kimberly's version of SP Help Index, which is free. All you have to do is do a search on SQL Skills Help Index. You'll find it. I install it on all the SQL servers that I happen to manage. Anyway, let's turn on actual execution plan. And I'm going to run this simple select statement where I'm selecting the last name, first name, and zip code. Remember, those 3 columns were part of my non-clustered index. Those are the index keys. Okay, and I'm going to do it where last name is equal to Smith. And then first of all, in the execution plan, we did an index seek. I went straight for that where last name is equal to Smith record, and I was able to find it. And now we're going to look at the messages tab here, because earlier I turned on set statistics IO, which is going to show us the number of logical reads that we had to do. Number of logical reads, for what it's worth, is the number of data pages I had to read in order to find the data, the data records that I wanted. Data page is an 8 kilobyte construct. Think of it as the number of boxes. Like if you had a room full of boxes, right? How many boxes did I have to search through in order to find something, right? Deborah and I recently moved, so we definitely had a lot of moving boxes full of junk. And where do we stick that thing for the kitchen? I don't know. Go search through all the boxes in the kitchen to go find that thing, right? So, we definitely had to do that for quite a while. So I'd rather search through only 2 or 3 boxes rather than 60 different boxes, right? Think of it in terms of that. So in this case, simple case here, we only did 6 logical reads. That was really, really fast, relatively little amount of work. Now, how about this? We need to make a change to that select statement. It's just like a business requirement changes. Hey, the application, we now need to return another data point. In this case, instead of just last name, first name, and zip code, I also need to return the email address. So, okay, yeah, I can modify the query to return the email address, no big deal, but we forget to update the underlying index that we created to originally support that query. That's a very, very common use case. So then this query gets deployed out to production with the next app upgrade, but we don't ever make any changes at the non-clustered index. And as a result, our execution plan changes, and now we have the dreaded key lookup that has now snuck into our production code here. So, we're still able to do an index seek here, but then we must do that extra operation to go get the email address. Now, remember the previous query, 6 logical reads? What do you think we did here? 1,485. That's a heck of a lot more than just 6 logical reads here. So, I mean, this is demo code, of course. So these are, just relatively speaking, small numbers. But this is stuff that adds up. Or if you think of it in percentage increases, how much of a percentage increase is 1,485 over 6, right? That's a huge, huge, huge difference. Now, what if we didn't have any predicates here? Would this behavior change a little bit? I'm going to do a select top 200,000 against the customer table, first without the email and then with the email as well, just to see some of the differences here. Let's take a quick glance at the execution plan. In the first case, we were still able to make use of the non-clustered index, and we scanned it. So we scanned the entirety of it. But in the second case, we can't even make use of that non-clustered index anymore. SQL Server says, forget that. I'm just going to scan the entire table in of itself, which is a larger construct. And as a result, the difference in logical reads is still tremendously different. Even though we did a full scan of each, the full scan of a non-clustered index was still only 887 data pages because it's a smaller construct. There's less data points in there, as opposed to scanning the entire table, almost 3,000 logical reads here. Again, a huge percentage difference and a massive amount of work differential there, okay? So let's modify this non-clustered index now. I'm going to include the email address, which is what we should be doing. And again, this is why I generally like these types of key lookups, because oftentimes it is low-hanging fruit, because oftentimes it's just 1 or 2 extra columns. So you know what? It's usually worth the trade-off. Not always, but usually worth it. Keywords there. So now let's rerun our example queries. So these are the select statements with the email. First with a predicate, and then one without a predicate. With my execution plans, in both cases, we are able to make use of the non-clustered index in question. I don't see a key lookup operation in either of these. And then the second one without the predicate, we were able to use the non-clustered index once again, rather than just defaulting and going back to the base table. And then in the messages tab here, 9 logical reads as opposed to 6, not bad, and 1,600. So, the non-clustered index did grow a little bit because, of course, we added in an extra data point of the email, but it's still better than scanning the entire base table of nearly 3,000 logical reads. So that's where the advantage comes from. Things are a little bit of a trade-off, right? That's one of my key mantras about SQL Server. A lot of the decisions we make in SQL Server are trade-offs. So Andy, that's really cool, but how do you detect whether you have a lot of these key lookup operations and whether they're occurring today in your environment? Well, there's some really cool ways that you can discover this. I'm not going to rerun this part of it, but instead I'm going to jump down to here. There's a fellow out there named Jonathan Cahayas, who's also part of SQL Skills, a fantastic group of folks that blog, and they're consultants and all that kind of stuff. And Jonathan wrote a great blog post and some code to help you find key lookup operations by going through the plan cache on your behalf. So be careful about running this in production, because it is scraping and data mining the plan cache. But if I run this right now, I will see the SQL text and the code that actually was run earlier, the initial things that I ran, the number of times I ran it, and so on and so forth. And the blog post in this code will fully talk about exactly how you can make use of this information. But nonetheless, this is stuff that you can now leverage to say, oh, here's some queries and here's some execution plans that I need to go make some adjustments for, and so on and so forth, so that I can, again, help out my workload, reduce that overall IO behind the scenes. So that's our first demo of one of the anti-panners, and I see that we still have a few minutes left. So we do have time for the other demo that I wanted to run here. So this is all about unexpected use of TempDB. So for this, I do need to switch back to my compatibility level to 2017, because funny enough, SQL Server 2019 breaks this demo because of improvements that they've made. That Microsoft has made. Okay, so I do need to create a covering index on my sales history table. So that's what I'm going to be doing right now. And then we have a task. Get all sales history records where the sale was higher than each salesperson average sell price. So I come up with this particular query where I'm selecting a bunch of stuff. And then in my where clause, you know what, because I have to do this thing around the average salesperson, I'm actually going to put in a sub select in the predicate here to calculate the average sales price and that sort of thing. And then you know what, because I want to make sure that I'm kind of limiting this, I'm actually going to say where salesperson ID is less than 140. Because that's going to cut my result set in half because I have about 300 or just under 300 salespeople in my salesperson table. So this was actually a funny little experiment that I was trying to do for something else. I thought it was actually going to help things out, and it didn't. And you'll see why in a moment. So I'm going to turn on actual execution plan and run this guy here. And yes, there are a couple of different anti-patterns in here, such as doing a select within a where predicate like this. But what's really happening here is that even though we have a non-clustered index that's meant to support this, we have what are called spool operators that suddenly appeared in this particular execution plan. This was something that was completely and utterly unexpected when I first was putting this together. I was actually trying to eliminate these. But what SQL Server is doing when it creates a spool is that it creates a temporary table on the side on its own because it has to create a subset of data and then it's doing some additional work against it. So it's actually creating several of these different spools or temp tables, as you can see inside the execution plan. And this has consequences, particularly in the form of logical reads. So it created multiple work tables, even though it only shows one work table here. It hit it 12 different times for a total of 2.7 million, almost 2.8 million logical reads. So that's a whole heck of a lot of referencing back to that data here. Even though in the end this thing only came up with about about 500,000 records. But you know what? It still did a whole heck of a lot of work behind the scenes here because I followed a couple of different anti-patterns. And really, the moral of the story is that I'm trying to do a couple of different things all in one single statement here. Because the thing is, should I have calculated the average out ahead of time and then maybe put that into its own temporary table, and then I could do my second inquiry against it? That's really the key here. Because remember the whole thing about coming up with that execution plan that's good enough, but I threw a recipe at you guys that had 21 different steps. This is a case where instead of one statement, you're actually better off breaking up this problem into multiple different statements and passing those statements in individually. A lot of us as developers are taught write less code, not more. So in this case, it translates into write less statements, and just write one statement that has everything in it. No, you're better off breaking things up and giving SQL Server a fighting chance, the query optimizer a fighting chance here. So what I'm doing in this example is now I'm going to create a temporary table called temp average price. I'm going to dump into this temporary table the salesperson ID and the calculated average sell price. And then I'm going to do a join against a temporary table with sales history information to get everything else that I need. So this is me breaking it up. So yeah, I'm running a bunch of different statements here, like what, 5 or 6 instead of 1. But on the other hand, from a messages perspective, from an IO perspective, if I go through here and total everything up, yeah, I'm still doing the 12,000 over here, but against the temp table over here, just under 600 logical reads. That's a heck of a lot better than 2.8 million logical reads. And then I can scroll down here because of course we have a couple other references to it. But long story short, if I total up all of these, I don't even get anywhere close to even 10,000 logical reads here. Or it's like, or not 10,000. It's like 10 or 20,000 logical reads. I forgot exactly what the number is, but it's still a fraction of 2.7 million logical reads here. Again, you're reducing all of this behind the scenes stuff, even though these queries all ran really fast. Keep that thing in mind. These all ran really fast. So you might say to yourself, well, who cares? They're all running really fast, Andy. Why should I really care about reducing from 2.7 million down to, a few thousand logical reads? Well, here's the thing. A lot of people don't think from a workload perspective, and that's the other thing when it comes to performance tuning. We're sharing resources on that SQL Server, and generally speaking, it's not just your query that's running. You're running alongside a whole bunch of other people, and you all have to share those same resources. So when it comes to performance tuning, you got to think about how you're sharing everything, and therefore, because you're sharing everything, you really want to try and minimize what it is that you actually need, so you're not fighting for those resources. So a number of different morals of the story are embedded embedded in this particular demo of, reducing your IO, breaking up the problem into multiple different statements and that sort of thing, right? So, but again, this is a survey session, and so I'm trying to throw a lot at you all at once. So to that end, let's kind of wrap things up and bring it home now. So Deborah and I talked about how we have a whole bunch of resources here. So all of these slides are available up on my GitHub, which will be on the final slide here. But there's a lot of fantastic resources out there. This book by Grant Fritchie, the first edition of it was my very first SQL Server book many, many moons ago that I learned about how to read execution plans. Eric Darling's got some really cool stuff about stop writing big queries. Kind of what I tried to compress in that final demo of mine. Michael Swartz got another awesome blog about that, and so on. Let's see, there's more stuff about execution plans here. The presentation that Deborah referenced earlier by Forrest is referenced here. Hugo Cornelis has done a phenomenal job really, really digging deep into execution plans on his website, SQLServerFast.com, and there's some phenomenal content on here. Plus video training if you really, really, really want to get more intermediate and advanced. Hugo's got some fantastic material out there. Just wonderful stuff. Of course, let's focus on, or, talking about key lookups and whatnot. Here's some other folks who have done some stuff about key lookup operations and whatnot. So you can definitely leverage some of these. And then the one thing when it comes to performance tuning is that even some of the best performance tuners in the industry don't know everything. So leverage the people that are out there. Leverage folks like us who hang out on social media, on Twitter and the SQL Help hashtag, or the SQL Slack community and other places. Ask questions, because that's how all of us as performance tuners learn. We go to each other and we all ask each other questions on a daily basis. You don't have to go this alone. So with that brings us to the end, and it looks like we managed to clock in at exactly 1 hour, so yay to us. And with that, let's open it up and see if there are any questions.
That was awesome, guys. Thank you.
You're most welcome.
I did see one question that hit the chat, but I think it's Jonathan's, and we can put it till later. It was just going over the differences between Oracle and SQL Server regarding cursors.
In a nutshell, so here's the thing. I don't know enough about Oracle. So where the story comes in from, so I got a story here. So a number of years ago, I interviewed for a job at a major financial firm, right? And that financial firm basically, they were hiring a SQL Server expert because they were migrating off of Oracle to SQL Server. So the manager sits me down for my interview, and the very first question out of his mouth was, write me a cursor. And I'm like, are you effing kidding me? No, I don't know how to write a cursor off the top of my head because it's one of the worst constructs in SQL Server. But you know what? I'll do my best anyway. And I kind of wrote a garbage cursor, and I didn't even remember half the syntax. And of course, I failed that interview. And then later on, I went on to find out that, again, in Oracle, cursors are a good thing. You should be using them all the time. Whereas in SQL Server, yeah, you really should not be using them because of how awful they are in SQL Server. But the manager wasn't, had an Oracle background. They didn't have any SQL Server expertise in house. That's what they were looking for. So I found it kind of funny that I failed because of that Oracle nuance. So that's where that story kind of came from, and that's how I learned about that. So I don't know the nuances of exactly what Oracle is doing behind the scenes because I'm not an Oracle person. I don't want to be, but I do know that cursors are good in Oracle and used very heavily, and it works just fine there. But again, SQL Server, no.
Yeah. Meanwhile, my first learning to write T-SQL, I had to write, I think it was SQL Server 6.5. I knew just enough 7.0 to get me this job, and I had to go back to SQL 6.5. And so really digging into T-SQL, my first thing I had to do was write a script running cursors on temp tables. So people don't like it because of the way it uses memory and the way you had tempdb set up. And so that's where it's just like, yeah, my introduction was knowing that I had to use a worse practice because that's what required because the database design was so bad.
I asked about the Oracle stuff because I think I have a few former Oracle developers where I'm at.
My condolences.
Well, again, it's the row by row action. And I think there's something with the way the Oracle processes things with row by row, where SQL Server, we want to get all the rows at once because the row by agonizing row, and the way SQL Server has to hit the same table multiple times. And a lot of times as you show them, hey, if you write it without and see how much faster it is, they learn quickly that to get rid of it.
Mm-hmm.
And also locking mechanism if you use the wrong cursor type too.
So one thing real fast that I forgot, to everyone who's hanging out with us still, thank you again, by the way, but could you
Yes.
do us a favor? In lieu of feedback, could you just give like a quick +1 or -1, depending on whether whether this session kind of met your expectations, whether it was helpful or useful for y'all. You don't have to write anything major, but if you wouldn't mind just throwing in like a quick +1 or a -1 or a 0, just to kind of gauge, hey, did this meet or exceed or not meet expectations, right? And if you're willing to give us any constructive feedback on how we can improve, well, of course we'd love to hear it. You're not going to hurt our feelings, so if there's any way we can improve this session, we'd love to hear from you guys. But again, a quick little +1 or -1 would at least just kind of help us gauge whether, like, did we hit the mark or not, right? So thank you so much, I appreciate that. So
I love that feedback that just hit the channel. This is, I didn't know about the properties tab in SMS for execution plans.
See, I always found the properties window annoying. And so like it'd pop up and like hide. Why would anyone ever want to see the properties tab? And it was a couple years ago that I was seeing something, and I think it had to do with the cardinality estimator. And then you started realizing, wait, there's all this really great gold in this properties tab. And so now that you start doing it, it's like, okay, so what information do I need? And then you can start exploring it more. And it's like, I felt like an idiot. I wasn't utilizing it. So I'm glad. I hope it's a useful tip for you too.
yeah, I too had a similar experience in my journey with execution plans. I didn't realize that there's a bunch of extra junk, not junk, but extra data, shoved inside that properties tab. I thought everything that I needed to know was in the tool tab. I'm like, wait a minute, there's all sorts of other stuff in this thing, dude. Mind blown,
And the crazy thing is, half the information that's there, it's almost impossible to use all of it. So especially if you're a beginner, don't worry about trying to learn every single property and all the details of it. Some of those, like we see these numbers, and honestly, they're almost meaningless. They're used for a guide. They're what SQL Server uses for the calculation. So we may not care about it, but it's nice to see it. But if you don't understand it and it's not relevant to what you're trying to fix, move on to the thing that is relevant to what you're trying to fix. So don't try to learn everything, especially everything all at once.
And performance tuning is an ongoing journey. That's the thing. You're constantly learning new things. It's not a true science. I mean, because one thing that people ask me, especially in the context of my job, is that is there programmatic magic buttons that can fix this? Unfortunately, the answer is no, because if there were, then Microsoft would have already put those fixes into the query optimizer, and we wouldn't need to worry about giving it crappy code, because the optimizer would magically fix it all and make it run with it in an efficient way. So the thing is, there is a little bit of art to it, and also it's because the query optimizer is slightly somewhat of a black box, there is a little bit of guesswork around it as well, which requires some experimentation. One of my favorite analogies, think of it as if you were in a restaurant and you're ordering dinner, right? But you're not going back into the back of the kitchen and telling the chefs back there, hey, you need to do this, and this, right? You're just sitting out in the dining room waiting for your dinner to show up, right? I really shouldn't be talking about food. I'm hungry. And it is dinner time for us. But in either case, it's like, think of that as the black box. Like the kitchen in the restaurant is that black box. The query optimizer is are the chefs back there that are making dinner for you. You might have an idea of what they're doing. Like if you're getting a steak, I assume they're throwing it on the grill and that sort of stuff, right? But you're not telling them, do this, flip it now, and and so on and so forth, right? So
well, and to expand on that, I've always said that performance tuning isn't baking, it's cooking. Because with baking, you have to have the exact measurements. It has to be just this, it has to be just that. With cooking, you can kind of throw a little bit of this and maybe that's too much, or you go a little bit that way and you're testing it and you're making sure, and you taste it to make sure it tastes right. And, depending on the humidity outside or the, the server underneath, or, what else is using that memory, that can affect that dish. And so that's why it's not an exact science. It's something you have to experiment with.
I love that.
I feel like Andy may be stealing that from you.
And that's okay if he does.
I'll try to make sure he gives you credit when I can.
It's all good.
Christian said, "I like the teamwork." Thank you very much, Christian. I'm glad that you like that, because this is actually the first joint session that Deborah and I have done together. So I'm glad it worked for you. So thank you for that bit of feedback. So if you didn't know, or if you were late, I am upstairs from Deborah right now. I am her personal chef.
He is.
You're lucky.
I mean, I get spoiled.
Well, I think he gets spoiled back because you're pretty awesome too. So.
Aw, thank you.
So does anyone have any other questions that they want to ask? You are not going to find better performance tuners, honestly. So this is a good time to ask.
Yes, my room is smaller, so no, I do have the smaller office, but I don't mind. It's actually quite cozy, and I actually have fit a standing desk over here and whatnot, so I don't mind it. So my little man cave is definitely more than enough for what I need.
Awesome, awesome. We really appreciate you guys. Thank you so much for all the help. Oh, that's a great question. Ideas on how to start doing these performance tunings in a disaster situation.
Ooh, those.
So so here's my 2 cents on it. One is that as you gain more experience as a performance tuner, you're going to start figuring out some of the different common methodologies, if you will, especially as you get to know your workload. That's part of the bigger key, is to know your workload, because every single environment is a little bit different. You know, are you stuck in an ORM entity framework hell, for example, or are you stuck in a SharePoint kind of hell, like a data warehouse type scenario, or are you in a highly transactional environment? All of those different types of workloads will take a slightly different approach, right? You know, are all your SQL servers, you know, like really dinky little tiny crappy little SQL servers, or do you have like one big massive SQL server that's got terabytes of RAM and all sorts of other stuff? Again, we'll take a slightly different approach. So the thing is that as you start getting to know your workload, you're also going to kind of start coming up with, or what you should do is start coming up with a list of different ways to approach it, because you'll also hopefully start learning some of the common things that go wrong on a regular basis. Your usual suspects, if you will, right? In my environment, and blocking happens all the time, or in this environment, deadlocks happen all the time. So you start coming up with those list of things to kind of start looking at on a fairly regular basis, or I'm always under CPU pressure or things like that, right? And then to build upon that, if you don't have a really cool monitoring tool, you should look into Azure Notebooks, and use some of the existing diagnostic queries that are out there. There's lots of them that many people have created, and create some kind of run book. And Deborah, I know you can talk a little bit about Azure Notebooks on that level.
You mean SQL notebooks?
Or yeah.
SQL notebooks, Azure. Yeah, no, there's definitely stuff about that. I mean, and again, it's like if you're talking disaster situation, it's also one of those. You have to identify start finding out which things are involved with the blocking, or if that's blocking. So defining what the scenario is, so you can narrow it down to which queries are involved. I remember doing deadlocks and way back, and all the trace flags, so you can figure out what queries are involved, and so then way you can figure out what the things are involved. When we've had some recently, it's like we've had the monitoring tool. Okay, which blocking are we getting? And so we can start figuring those things out, and then we can start examining the queries. And then we can start saying, okay, let me get this in a different place where I can run this, see what the execution plan is. Maybe you have query store, so you can get the execution plans from query store and using some of the DMVs to find those. And so once you narrow it down to your problem statements, you can find the execution plans. And then you can start going through those, saying what's your problem points, which one is costing the most, if you can find which indexes are being used, which ones are, and then you can start working through there. It's also knowing your database, knowing some of those things, and working your way through. It's horrible in a disaster situation because people want you to find it instantly, and they're like, why haven't you solved it yet 10 seconds later? And it's like, well, it's, I don't know yet. Or it's the fleeting thing. It's like, well, it happens here, not there. So, but I would start by trying to narrow down the queries. If you can get baselines and you can find out which ones aren't great before the disaster starts, it may help give you that head start. So it's like, oh yeah, I know this query. I was just working on it. We have the fix. It's coming tomorrow, or something like that, which also makes you look like a hero because you've solved the problem. just when the client needs the solution. So it's walking yourself through those steps.
I was going to recommend both Query Store and Who is Active for getting to know
Yes.
your database and your data, and do that before the disaster happens.
Yeah, I mean, it's hard to, but those are excellent,
Mhm.
excellent places to start.
In addition, Brent Ozar's got his Blitz scripts out there. Eric Darling has built some additional scripts because he was one of the original architects of the Blitz scripts, but he's got like a memory pressure detector and a CPU pressure detector or something like that. I forget what they are these days. And if your company is willing to spend some money, go look into some paid monitoring tools as well. I happen to work for one. I'm not going to pitch them right now, but in either case, hopefully you're doing some kind of monitoring, some kind of capturing of information in some way, shape, or form, whether it be using some of the free options that are out there or even using a paid option of some sort.
Oh, there's some really good questions that have just shown up in chat.
Yeah, you want to hit the next one?
Any
Scott?
thoughts on on-prem SQL Server tuning versus Azure DB tuning? So this is my confession where I haven't done too much with Azure DB tuning. But if you can get execution plans and do query, can you do execution plans on when you're connected to an Azure database?
Yes.
Because I think, yeah. So you should, if you can get a look at your execution plans, you're going to want to do that. There's definitely going to be some things that you can or can't do depending on what your queries are. But if you can get an execution plan, a lot of these things I would say still apply, I believe.
Yes. So the secret behind all of this is that the storage engine and the query optimizer on SQL Server on-prem and Azure SQL Database are identical. The only main difference is that in Azure, Microsoft is actually iterating more rapidly. So you may actually have more hidden functionality in there, and they may be using you as a guinea pig, if you will, as opposed to SQL Server on-prem, of course, where you got to do the upgrades yourself and stuff. But otherwise, the point is that it's the same query optimizer. It's the same storage engine. So the same methodologies that you employ on-prem, you can effectively employ them up in Azure SQL DB. Obviously, there will be some limitations because of the way Microsoft controls stuff and whatnot. But from generally speaking, though, the other thing that I would say to keep in mind when it comes to Azure is that you're paying for compute. So it is, as opposed to on-prem. You buy some hardware, you own that hardware, you can max that hardware out and you're not paying any extra for that. In Azure, you're paying for a certain caliber or service level of compute. But if your code is really crappy, you're going to wind up needing to upgrade and tier up and whatnot. So in some regards, it's actually more in your best interest to tune the heck out of all of your code as best you possibly can to reduce that compute and therefore reduce your costs up in Azure. So so it's one of those things of performance tuning is not going away anytime soon as people move their workloads up to the cloud. In some regards, performance tuning is becoming even more important and more paramount in order to help organizations save more money.
Next question we have is, if you cannot access the SQL Server directly, is there a way to do remote tuning, especially with customer data that is secure and they will not share with you? So there is the one thing that popped to my mind is a lot of the reasons why we have issues is because we test in dev and even our QA, we don't have like the heavy loads that our clients have. So our statistics are off, so we don't necessarily see what's missing. So there are a couple different options. I think you can get, if they're having problems and if they've got Query Store, I believe you can either anonymize the query plan a little bit, and so you can get some of that information. But the other thing is you can actually script out the database with statistics. You're not filling out the data, but you're doing it through Management Studio, and you're scripting out statistics. So what you're doing is you're getting the client statistics. You're not getting their data, but you're getting information about their distribution. And so you can actually create a database, apply those statistics, and you can actually even though you don't have their data, you can almost see some of those things. So it may be a way for you to kind of create a mock version of it. But again, it is really hard when you don't have their data. But that's one thing a technique I've heard of, that you can almost emulate that information, but still not with their data. But it's because it's the statistics that SQL Server is using to create those execution plans. Now you have to make sure you don't auto update your stats, because that will throw everything off. But you know, again, if we need the statistics to figure out what the execution plan is, you could fake it.
Yeah, and building upon that, I mean, it's really, are you able to at least get exec plans out of them and whatnot? So, you know, on the reverse side of things, you know, I talk about a lot with my customers of how you can leverage our monitoring tools to basically grab the execution plans that are actually happening. And this is in the context of, you know, hey, you know, you happen to have a third-party vendor app. So, you know, you need to send like the vendor, you know, here's how your terrible code is going sideways in my production environment. Now you need to go fix this, right? So, you know, a good monitoring tool can capture all that kind of information without sending the actual customer data around. It can capture the full call stack, it capture the execution plans, the deadlocks, the blocking XML, and all that kind of good stuff, and then send that back to the vendor. The more information you can send back to the, you know, that you can send over and pass over, the better. And, you know, the things like what Deborah talked about, being able to at least have the stats allows you, you know, to get estimated execution plans, because estimated execution plans are based upon the statistics. It doesn't look at the data at that point. So, I mean, you know, but the thing is, yeah, remote tuning without direct access is quite a challenge, because you need, fundamentally, it's because you need statistics. You know, I don't care what your data is. I want to know what your stats are first and foremost. So. A Synapse. So I don't deal with Synapse, so I can't make any commentary on that. And I'll speak for Deborah. I know she doesn't either. So
Yeah, unfortunately, I don't have that information, but I'm sure there's great information out in the community. And as Azure Synapse is becoming a lot more popular, I bet there's going to be a lot of resources coming out about how to do performance tuning.
All right. Any other questions from anyone in the audience?
That was so good, you guys. Thank you so much.
Our pleasure.
Yes, thanks so much for having us. And thanks everyone for
Yes.
attending. Thanks for being here.
Thanks for all hanging out for the Q&A and for the BSing.
Hey, that's the best part, right?